So I am giving one problem on this method, later you do. Okay, let me second example, which is given 2011. If the starting value is x is equal to 2 for the iteration of the equation fx is equal to x plus root x minus 3 is equal to 0, then the value of x that is to be used in the next step by NR method, comma is, you check, answer is, I am giving 1.694. Next, third example, which is given 2007. Consider the series xn plus 1 is equal to xn by 2 plus 9 by 8 xn, comma x0 is equal to 0.5 obtained from the NR method, Newton-Raphson method. Full stop. The series converges to A 1.5, B 1.6, C root 2, D 1.4. So in this I am giving hint, f dash x is equal to x derivative 1, root x derivative 1 by 2 root x, constant derivative 0. Then you calculate. Now I am going to do this problem. Xn plus 1, xn by 2 plus 9 by 8 xn. Okay, say equation 1, comma x0 is 0.5. Initial value is given, starting approximate root of the equation x0 given, and this is some iteration formula using the NR method, it is given. Okay. Now, what is the meaning of the series convergence? What is the series? Here the series means collecting all x values, x0, x1, x2, x3, like that. That is called series. So, when it is converges. So, generally, after a lot number of iterations, that means convergence means going to exact answer. When you will get exact answer, that means in the general case I am discussing, in any method, n tends to infinity. That is lot number of iterations. Okay. If n tends to infinity, then the series, that is x0, x1, x2, so on, xn, xn plus 1, so on, converges. To root, and xn is equal to xn plus 1 is equal to alpha is a root of the equation. See, whenever n is going to infinity, there is large number of iterations. The series, this is converges. In this case, xn is equal to xn plus 1 is equal to alpha. Alpha is the root of the equation. After doing a more number of iterations, that is lakhs, crores, that is n tends to infinity, then the last two iteration values must and should be same, that is equal to your exact answer, that is alpha is the root of the equation. Now apply n tends to infinity in equation 1, we get alpha is equal to alpha by 2 plus 9 by 8 alpha. This simplifies to alpha by 2 is equal to 9 by, bring alpha by 2 left side, simplifies to alpha by 2, cross multiply. So alpha square is equal to 9 by 4, alpha is equal to plus or minus 3 by 2. So therefore alpha is equal to 1.5 or plus or minus 1.5. But according to the option, no negative value. So option is A. Light grass. Light grass. Next, iterative formula, one of the application for finding square root, cube root and reciprocal of a given number n. Using Newton-Raphson method, I am going to find the direct formula, Newton iterative formula. After that, you will be giving n is equal to 0, 1, 2, 3 like that. In this first one, let given number is n. We are going to find square root. Square root of n. We don't know that value. Let us say x, okay, where n greater than 0. Square root exists for positive numbers only. Now to avoid square root, that means bring an equation without square roots. That means squaring on both sides and bring all the terms to one side is an equation. That is given equation of the form fx is equal to 0, where fx is nothing but x square minus n. So here we are going to find square root of a given number. So consider that value x, we don't know. Now to find iterative formula, you have to get an equation. How to get equation? Because we are going to find square root, then squaring on both sides and bring all the terms to one side, so that you will be getting fx. Now in this, what is f dash x? 2x. The NR, Newton-Raphson iterative formula is how much? xn plus 1 is equal to xn minus fxn divided by f dash xn. What is xn? We don't know. What is fxn? F dash xn. In fx, f dash x, substitute x is equal to xn. This gives xn square minus capital N divided by 2xn. Taking LCM, 2xn and xn, 2xn square minus xn square plus capital N divided by 2xn. So what is the formula now? Therefore xn plus 1 is equal to xn square plus capital N divided by 2xn. Okay, is the iterative formula for square root n. N is equal to 0, 1, 2, so on. Please by heart this relation. Sometimes it is useful in problems. Without finding f dash every step, x1, x2 we are finding f dash, and then we are substituting that x value, and we are calculating x1, x2 using NR formula. That's in some problems it takes less time, but in some problems if you get directly a recurrence relation, that is iterative formula, and then giving n is equal 1 by 1 value, which takes less time or less number of steps. So this method avoids at every step evaluating its derivative f dash. Better to remember as a formula these three relations, these three terms: square root, cube root, reciprocal. Now cube root denoted by this symbol n is equal to x. Say we don't know that value, I am taking that x. Now to get an equation we should eliminate cube, that means cube root, cubing on both sides, and then bringing all the terms, which will give us an equation denoted by fx is equal to 0, where fx is equal to x cube minus n. Now what is f dash x in this? 3x square. Just refer above, as above procedure. The NR iterative formula is xn plus 1 is equal to xn minus fxn by f dash xn. Xn minus, what is fxn, f dash xn in this? Substitute x is equal to xn. Xn cube minus n divided by 3xn square, which implies, I am writing directly after simplification as above, this is going to 2xn cube plus n divided by 3xn square. N is equal to 0, 1, 2, so on. Is the iterative formula for cube root of a given number. Third one is reciprocal. Reciprocal of a given number denoted by 1 by n. Let us say x. We don't know that value. So to get an equation, again reciprocal on both sides. So n is equal to 1 by x, which implies I am getting an equation 1 by x minus n is equal to 0. Let us say this left side let us denote this left side by fx. From this f dash x, 1 by x derivative is minus 1 by x square using x power n derivative n into x power n minus 1. Next, the n are iterative. N is a constant derivative alone 0 is xn plus 1 is equal to xn minus f of xn divided by f dash xn. Substitute fx f dash x here. So therefore xn plus 1 is equal to xn minus fxn, 1 by xn minus n divided by minus 1 by xn square. So this is xn plus xn minus n into xn square. Therefore xn plus 1 is equal to 2xn minus n times xn square. N is equal to 0, 1, 2, so on, comma. He is the iterative formula for 1 by n, n not equal to 0. GN వస్తుంది లైట్గా. Some problems first consider the iterative formula, then simplify, and then go on giving n is equal to 1 by 1 values. Some problems at each step find f value and f dash value and then find x1, x2, etc. like that. Depending on the problem only, it takes less number of steps or less time like that. Okay, depending on the problem. The next one is secant and regular falsy method. Regular falsy method. Let f of x be continuous function and x0 comma x1 be two initial values such that fx0, this is also denoted by f0, and ffx1 denoted by f1. Initial values means starting value. Okay, not required, starting values. Are of opposite signs. Say fx0 less than 0 and fx1 greater than 0. That is two starting values. Instead of two initial values, that is also called two starting values, guessing values. So here two initial values, that is two x starting values approximation roots. The two x0, x1 are the starting values which are approximations to the required root, okay, which are the initial approximations to the root. In the previous problem, x0 is the one initial approximation, starting root, that is initial approximation root, that is also guessing value. But in regular falsy and secant method, we have to start with two initial approximations to the root, okay, in such a way that their function values are of opposite signs. Then the regular falsy, RF means regular falsy, iterative formula for finding root of the equation fx is equal to 0 is xi plus 1 is equal to xi minus 1 f of xi minus xi times f of xi minus 1 divided by f of xi minus f of xi minus 1 for I is equal to 1, 2, 3, so on. In particular, for I is equal to 1, comma, x2 is equal to x0 f1 minus x1 f0 by f1 minus f0, say star. So this is the regular false iterative formula. I already denoted f0 short form f of x0 and f of x1 is also in short form f1. So if you take here I is equal to 1, which gives x2, this is x0 f of x1 denoted by f1, this becomes x1 f of x0 denoted by f0 divided by f1 minus f0, let us say star. Now I told you in bisection or whatever the method, whenever you get a new x value, latest x value, immediately substitute that x value in the function and decide the nature, function value greater than 0, equal to 0, less than 0. Case 1, just like in bisection, if f of x2 is equal to 0, then x2 is root and stop the process. Case 1 over, case 2, case 3, just like bisection method only. If you have a time, just refer bisection method, how I discussed it. Same, a small change only in this method. How I computed their x2 in case 2, case 3. Case 2. If fx2 greater than 0, comma, compute x3 by replacing x1 by x2 and f1 by f2. What is f2? F of x2. f1 I already given. In star. That is x3 is equal to in star, because fx2 greater than 0, already previously one of the function value less than 0 where we got f0, f of x0 less than 0. That means in the second case your location, that is the required root, lies between x0 and x2. So that's why in this star f1 replaced by f2 and x1 replaced by x2. So how much now? x0 f2 minus x2 f0 by f2 minus f0. Okay, since f of x0 less than 0, therefore root lies between x0 and x2. Earlier root lies between x0 and x1 because I have taken fx0 and fx1 are of opposite signs. Now here fx0 and fx2 are of opposite signs because fx0 less than 0. So your latest root, I mean your latest interval, your required root lies between x0 and x2. So in this f1 replaced by f2, x1 replaced by x2. Case 3. If fx2 less than 0, so that means in this case you find a function value greater than 0. Which of the previous greater than 0? fx1 greater than 0. That means root lies between x1 and x2, comma, compute x3 by replacing x0 by x2 and f0 by f2 in star. That is x3 is equal to x2 f1 minus x1 f2 divided by f1 minus f2. In this, since fx1 greater than 0, therefore root lies between x2 and x1. Just all these steps depends on star only. Whenever you get two latest function values are of opposite signs, then go to your star and replace that values. Okay. Continue the above process until the desired accuracy of root is found. Just write the same sentence in the end of the bisection method also. Where do you stop the procedure? Until the desired accuracy of the root is found. This method is also called method of chords. The Newton-Raphson method, method of tangents. Regular falsi method is, or false position method, which is also known as method of chords. What is chord? A line intersects the curve exactly at 2 points. That length intercepted of that line where it meets that 2 points, where it meets the curve at 2 points, the length intercepted, that is called chord, C-H-O-R-D. Now I am giving secant method also. Secant method. First preference is Newton-Raphson method, second preference is bisection secant, and the third one is regular falsi. That is the order of the preference problems giving in GATE question, GATE exam. It is similar to regular falsi method, except that x0 and x1 initial values need not satisfy the condition fx0 and fx1 are of opposite signs. Secant method does not provide the guarantee for of the root so it is unreliable secant method iterative formula for finding root of the equation fx is equal to 0 comma is xi plus 1 is equal to xi minus 1 f of xi minus xi times f of xi minus 1 divided by f of xi minus one, 2, 3, so on. Just here in the interval add this sentence. Now it is similar to regular false method except one condition. x0 and x1, that is initial values, starting values, need not satisfy the condition the function values are of opposite signs. That means the function values are of same signs also. This method is applicable. Okay, not opposite signs or whatever the signs, irrespective of the functional value signs, we can apply this method. So secant method does not provide the guarantee for existence of the root in the interval x0 x1. So because I told you, whenever your two function values are of opposite sign, then definitely your your final answer, that is root of the equation, lies between that x values. Here secant method not required to satisfy the condition fx0 fx1 opposite signs. So in some problems it does not exist, that root does not exist between x0 and x1. So this method is unreliable. The secant method iterative formula for finding the root of the equation is same. That's why it is similar to regular false, same method. Okay, similarly in particular like that. Okay, so whenever these two are equal, this is divergent. This method fails whenever two function values are equal immediately. Okay, fx0 and fx1 or fx1 and fx2 etc. Whenever these two coincident in a given problem, then this method is fails. In particular, for n is equal to 0, comma, x2 is equal to x0 f1 minus x1 f0 by f1 minus f0 star. So whenever f1 is equal to f0, this method fails. That is the disadvantages in this method. Similarly, for n is equal to 1, x3 is equal to x1 f2 minus x2 f1 by f2 minus f1 and so on. Here in this, not required to find everywhere fx0, fx1 and fx2, not need to check that they are of opposite signs like that. Just by putting I is equal to 1 by 1 value, you will be getting 1 by 1 x value. Example. So of all these four methods, the powerful method is Newton-Raphson method. Next powerful method is secant method. Next is bisection and regular false, having same in maximum problems take same time. Bisection and regular false method. Okay. Convergence is also faster in Newton-Raphson method. Next secant method. Next last two methods. Okay. One example which is asked in 2013. Applying the secant method, comma, the first approximation to the root of fx is equal to 1 plus ln x plus x by 2 starting with initial values at x is equal to 0.3, x is equal to 0.4, comma, is so here the function is solution. Fx is equal to how much? 1 plus natural logarithm x plus x by 2, base logarithm. x0 is 0.3, this is the data given. x1 is 0.4, starting values. By secant method, comma, what is x2 formula? There I have written. x0 f1 minus x1 f0 divided by f1 minus f0, where f0 is f of x0. What is x0? 0.3. That means 1 plus ln 0.3 plus 0.3 by 2. So calculate natural logarithm 0.3. This simplifies to minus 0.05. f1, f of x1. What is x1? 0.4. That is 1 plus ln 0.4 plus 0.4 by 2. This simplifies to 0.28. Please check all of you this thing. Therefore, x2 is equal to, what is x0? 0.3. What is f1? 0.28 minus x1 is 0.4. What is f0? Minus 0.05 divided by f1 minus f0. 0.28 plus this is simplifies to approximately 0.32. Later you check. According to the options is given like that. APP stands for approximately. I didn't give the options, but one of the options is 0.32. Please check.